Hey, good morning. Hope you guys had a nice weekend. I'm going to talk about how to factor quadratics now that have a value in front here. Right, let me blow this up a little bit. Right here, if we notice that this number right here is greater than 1. Okay, and that presents a problem for us because now we can't use what we did before to say what times what is equal to the last number that when we add equal this, because when we have our binomials, when we're done, we no longer have an n right here and an n right here. One of these is going to have to be a 2n, because that's the only way when we multiply we can get a 2n squared. Okay, so that presents a problem for us. Okay, and there's a way that we're going to learn next week on how to do those. However, for this week, okay, these problems, although they have the 2 there, if you notice, we can take a GCF out of here, and out of here. What is that GCF? Well, what's the biggest number that goes into 2, 14, and 16? It would be 2. Okay, are there n's that I could take out of all three? No, because the 16 doesn't have any n's. So the GCF is just 2. So if I take that GCF out, I have a 2 times, and what I'd be left with is n squared minus 7n minus 8. How did I get that? I just divided everything by 2. Right? 2 divided by 2 is 1, negative 14 divided by 2 is negative 7, and negative 16 divided by 2 is negative 8. And now what I'm left with, okay, is I still have that 2 out front, but now I have a problem like we did last week where a is equal to 1. Okay, so I'm still going to have my 2. Now I'm going to have 2 binomials. I'm going to have an n here and an n here, and I have to figure out these 2 numbers. And if you remember how we did that last week was we made an x, we put the negative 8 up here, we put the negative 7 here, right? I'm just going to move this over a little bit. Then we had factors of negative 8, right? And we had 8 and 1, and we had 4 and 2. Right? And we know that our factor pairs are 8 and 1, but one of them needs to be negative because when we add them, we need it to be negative 7. And when we multiply them, we need it to be negative 8. So if I want to add them and be left with a negative, the 8 needs to be negative. So negative 8 and 1, negative 8 and 1, and you are done. Okay, so why don't you pause it there and maybe go back and look at that again and just see how I took that GCF out. And when you're ready, we're going to move on to the next one. Okay, so in this one, we look at that 3 in front, okay, and we say, ooh, that presents a problem for us. So maybe we can factor that out. So what is the GCF? Well, the GCF is 3, right? Because 3 goes into 3, it goes into 33, and 3 goes into 30. So our GCF here, right? So even though a is greater than 1, we can factor that out because our GCF is 3. So we are going to take out the 3, and if I divide 3n squared by 3, I'd be left with n squared. And if I divide negative 33 by 3, I'd be left with negative 11n. And if I divide 30 by 3, I'd be left with 10. So now I know my answer is going to be 3 times 2 binomials. Okay? Those 2 binomials we can factor by putting the 10 up top. That's a bad 10. There we go. And the negative 11 on the bottom. What are factors of 10? Well, factors of 10 are 10 and 1. 5 and 2. So where can I get 11? I can get 11 right here. But if I need them to add to be negative 11 and multiply by 10, the only way I can add 2 numbers and have them be negative and multiply them and have them be positive up here, right, is if they're both negative. Negative 10 times negative 1 is 10, and negative 10 plus negative 1 is negative 11. My puzzle works. These are my two numbers. They will move over here into my factor pair, n minus 10, n minus 1, and you're done. And remember, these are interchangeable, right? I could have the negative 10 to the right and the negative 1 here. They'd both be correct. Okay, so that would be your answer right there. That is your final answer. All right. Now, we'll move on to the next one. You might want to pause it here and try this yourself and then see if you can follow along. Okay. Again, we look at that 6. We know that presents a problem, and we see maybe it's a GCF and we can pull it out. So, is 6 a GCF? Yeah. 6 divided by 6 is 1. 24 divided by 6 I can do. And 30 divided by 6 I can do. So my GCF is 6. So I'm going to have 6 times p squared plus 4p minus 5. Then I have a 6. I have two binomials here. I'm going to find those by saying factors of negative 5 that add to 4. My only factors of 5 are 5 and 1. One of them needs to be negative. I need to be left with a positive, so the bigger number needs to be positive. The smaller number needs to be negative. And I am done. P plus 5, P minus 1. Here's your answer right there. If you wanted to check your answer, if you multiplied these all back together, you'd end up with what you started with up there. So watch this over again a couple times. Try the worksheet. There's a quiz review online. Try that. Try the problems on there, which have a GCF in them. And let me know if you have any questions.